Okay, on to this next capacitor here. Put that number on there. What's that say? 563. So what would that mean? 0.0056? Is that what that means? I don't think that means that. So we're out on this tube. Which tube is this tube? This tube is 1C5 output tube. 1C5 output tube. Okay. One C5 output tube, and this is for pins. There's the key. 8, 7, 6 is a not used pin. 6, 5. So capacitor coming off of pin 5, heading over to this other tube. Pin 5, right? Now what's pin 5? There we go. 1C5, 1C5. So when do I ever get this right? 1C5. ABC, 1C5, power pentode, right on. Pin number 5, is that what I said it was? 8, 7, 6, 5. Pin number 5, 1C5 is the grid. So that's a pretty important capacitor. Pin and grid, on the grid of the 1C5. So the 1C5, we look at the grid. Bearing in mind that they've got these tubes drawn upside down from conventional. There it is. There it is. 0.01. It's a 0.01. Well, I got lots of those. 0.01. And boy, this doesn't get much easier than this. Particular one here. It's out in the open. Hey, how come they don't have radio repair in the Olympics? Or not just, as usual, the stupid thought always leads to an even more stupid thought. Why don't they have, like, surgery in the Olympics? Olympic dentistry. Actually, to think about it, we just expect all of our doctors and dentists to be Olympic level players, don't we? We just expect them to know everything and be really good at it. Sometimes those wires have a coating of wax or dirt and who knows what on them, and the solder doesn't Doesn't like it. And another one bites the dust, so to speak. Okay, who's next? Up this way. We have these two big ones here. So let's find out what they are first. Because, let's see, they're both on the same pin. And what tube is that? That is the 1A7. It's a detector again. Is that right? Guess that's right. 1A7. Pin number 7. 1A7. Pin number 7. Okay, so what is that? What's a 1A7? 1A7. Pin number, and I forgot it already. Pin number 7. What am I talking about? 1A7, pin number 7. No wonder I got confused. Oh, that's that heater pin again. What's the story on that? And that's a grounded. That's just a big grounding thing. So this is just a ground point for these two capacitors. So that's not going to help. The other one of them is connected to pin number 1, 2, 3, 4. Pin number 4 on the 1A7 is what is that? Screen and suppressor. Let's see, screen and suppressor, I would say. Well, they can't be. They're connected together internally, so 2 suppressors? I'm not exactly sure how that works. 2 screens? I don't know. But that's what they are anyway. The screen and the screen. Okay, so looking on the circuit diagram here, a 1A7. Why don't you join me up here, please? 1A7. 1A7. The screen. Well, they're not shown together on this diagram. They're all shown separately. Hold on, something not adding up here. 1A7. There's a 1A7. 1, 2, 3, 4, 5 grids inside the tube. The 1A7. 1, 2, 3, 4. What's going on there? It's not going to help. Okay. What else can we see in this radio here? Capacitor to ground right off of pin number 4. Pin number 4. What am I doing here? Hold on. Back up. Back up. Turn around. That's right. I got the wrong side of the capacitor. Don't worry about pin 7. Worry about pin 4. Pin 4. Yeah, pin 4 is that strange suppressor thingy grid. I don't know how that works exactly. This is kind of weird. My book shows more grids. I wonder if they're just showing one on the diagram because there's only one connection out of the two. They're just neglecting to put the extra grid in. That'd be pin 4. Okay, so if we look on here, yeah, this one. Okay, so which one of these would it be? It would have to be this one here, I believe. One. Oh my God! How am I going to figure this out? Well, one. Let's see. One pin. Hey, wait a minute. These pins don't have to be numbered. They have the key there. So if we do 4, 1, 2, 3, 4, you end up at this one. Exactly right. Exactly. That goes down. There's a capacitor. It doesn't go to ground. It does not go to ground. So, and the other possible candidate, what's going on here? Um, 1A7G. 1A7. 1A7. Is that not the 1A7? Have I got myself messed up here and I'm looking at a different tube socket? Let's try that again. Okay, so the 1A7 is right between the IF can and the tuning capacitor, and there it is. That's definitely the 1A7. I'm not mistaken about that. It certainly doesn't seem to add up right, does it? I think it must be, maybe there's more than one 1A7. This has happened, especially when you're back in this age range. Be a little bit surprised at that. Nothing else in the book here. No special notes. No hints of what's going on. It's a grid cap tube. Yeah, there's a grid cap there. What have you guys been looking at all this time? I'm kind of looking up in space. Well, okay, next objective. Let's forget about that little capacitor. Go for the bigger one, which comes over to this coil. And then a yellow wire goes from there back to this tube. Okay. Okay. Let's try. Wrong diagram. Let's get the right diagram. Which tube is that? That is the tube in the end. That's the 1N5. 1N5. Okay. So we now know that these are in fact numbered. 1N5. And we're looking at this pin, which is pin number 1, 2, 3, 4, 5. Pin number 5 on the 1N5. 1, 2, 3, 4, 5. Signal grid. Signal grid. There's a resistor off of it. A fairly large capacitor going to ground. Haha. There it is. 8 millifarads. Microfarads. Oh, wait a minute. Yeah, comes so we should also see a wire coming off there. Yes, we do. We see a wire coming off. And it heads for 1A7 through a resistor. There it is. I do see it, but wait a minute. That's coming off a different terminal. Hold on. Okay, let me straighten this out. I'm going to babble away and blow everybody's mind away. I'm just going to sort this out. Okay, so I think the best thing I can do, be a little more sure of the size of this capacitor, is cut it out. It's large. What do you think that says? Where's my magnifier? Hold on. Okay. Let's see what I can read on here. I have no idea what that means. It would look like 0.1, 200 volt. That's what I would guess that means, but I don't think that's correct at all. So cutting it out really hasn't helped out here. You need to be fairly sure of these things. So it's coming off of this is L8, probably L7 and 8. L7 and 8, there they are. So it's coming off of one of the 4 pins here. Oh, look at that. They're actually labeled. A, B, C, D. Oh, they're labeled right on here. How do you like that? My job's getting easier here. So this is coming off of A. Coming off of A. Poorly written A. Coming from the plates. Coming from the plates. That wasn't the plate. 1N5. Here we go again. 1N5. Round and around and around we go. Where we stop. 1N5. Plate would be pin number 3. There's no way. 3 is 1, 2, 3 here. That's going over to this other can. Other IF can. Oh, okay. I'm looking at this diagram down here from the top, not from the bottom. So, okay, I got it flipped over. So that's actually L6. Probably L5 and 6. Look, oh, man, L5 and 6. There they are, right in between the 2 tubes, just as it should be. Okay, now we look at A. Who ever wrote on here? That's very poorly done. That's got to be an A. So that's an A. There's a capacitor showing up there. That's across the coil, though. Not to ground. So we're looking for something to ground. There's nothing going to ground from there. Oh, yes, there is. We come back, we come over, we come down. 8. Okay, there it is again. That's got to be the guy there. I think that might even be the AVC capacitor. So, 8 microfarads. I don't have anything like that. 8 microfarads. How do you get there? Oh, man. I have to stop and ponder the situation once again. Okay, so 8 microfarad capacitor. I don't have anything that I can substitute for that within reason. I got nothing here. So, unfortunately, I can't change this capacitor right now. I've gone and cut it out, but I've marked it on the schematic here, so I won't forget it. We'll just carry on to the next one. The next one, I'm having just as much trouble identifying it. Let's take a look here. That guy right there. Now, we'll cut them out. this one here, not going to help me. Once again, doesn't have any meaningful markings on it. So here we go. Pin number 1, 2, 3, 4. From pin number 4 to pin number 5, 6, 7. From 4 to 7. 7 is grounded. 7 is the heater. That's the heater. That doesn't really matter. It's just a grounded point. So it's the other pin that's of interest to us. Pin number 4. 4 is the screen grid. Oh, I'm looking at the wrong 2, for God's sakes. 4, 4, 4. 1, 2, 3, 4. Still the screen grid. So capacitor coming off of pin number 4 to ground is a 0.01. Hey! Now those ones I've got. The fact is, I gotta get like, I gotta double or triple my range of sizes of capacitors here. So 0.01 just going in between there. That shouldn't be too tough. Okay. Here to there. Coming up on 12 noon here at my place. Like I said before, it's a nice sunny but cold day here. I have the feeling we're in for a week of cold temperatures. Man, it has been cold this winter, and I shouldn't complain because I know lots of people have been having weather problems all over North America. Obviously, it was all that rain in England. In fact, most people I'm talking to up here are saying, well, you know what? It's better to have a snowy, cold winter than one of these slush monsters that we seem to have been having the last 10 or 20 years. Just a winter of dirty slush. That's no fun. Okay, so that guy's in there nicely. And we're going to move on to what? Guess what? That's the last of the paper or unreliable capacitors. Oh, I got to do something about this point. I put it right back in. Let's see if I can test this guy a little bit. Let's give this one a good testing, and then we'll know what to do with it. Because maybe it's still good. So what we're going to do here, try to do. Oops. I'm going to hook it up to my high voltage supply here. We're going to put 150 volts onto it. See what happens. So those are the leads. Come on over here with me and we'll watch what happens on the meter, because that's where the action is on this. If you don't have any choice anyway, you're coming with me whether you want to or not. Okay. Now try and hold this as steady as I can. Let me bring the tripod over. Yeah, somehow in my small shop I've got a chair, a tripod, me, sometimes the cat. Now I think it's better if we have a steady camera shot on this. So the meter on the left is a voltmeter. The scale is 400 at the top. The meter on the right is a milliamp meter. The big red warning mark. Don't go above that red warning. So put her on. There's a little tiny bit of voltage already. You have to watch this. We'll take it up to 150. We're at 150. Absolutely no current leakage visible there. Nothing. Now, I'm for sure making contact with the leads over here. I don't know. Let's do a wiggle up. So I'm wiggling it with 150 volts on it. Here it is here. But I don't see any current change at all. Now I would have expected to see a charging current on a 8 microfarad. Better stop saying that. 8 microfarad capacitor. So it's a little odd to me. It's as if it has no capacity. 8 microfarads. I can read that on my meter. So let's kill this before it kills us. And you can see the voltage bled right off the capacitor quickly. Back here. So far that capacitor is indicating it's good. That's what it's trying to say. It's trying to say, I'm not a bad guy. But not sure about the capacity. Now, how could the capacity fall on this? Pretty tough. You know, without a short circuit. It does look to be in fairly good shape other than being dusty. I don't see any distortions in it. We have no option here. If we want to continue, I have to put this back in. So that's what we will do. We will reinstall. Then I will replace it, but it'll have to be after I get a replacement capacitor, obviously. If we want to carry on and actually get to test this radio, we need to put a capacitor in here for sure. Let me just move you over here a little bit. Okay. Luckily, there's still enough wire to put them back together. I'm just looking at all these other cracked wires in here. Probably no short circuits because of it, but If you move those wires, then you'll be replacing them. No doubt about it. Hopefully I don't have to move any of them. To some degree, all the insulation does is hold the conductor away from the other conductors. You might think there's some magic in some insulation. Yeah, but really all it's trying to do is just a way to keep the conductors from touching. Yes, there's more to it than that, but you know, in low voltage circumstances, the insulation is not doing anything electrical much at all. You know, these wires are real dirty. Dirty. I think I got it soldered there. Yep. So where are we now? We've changed out all the capacitors except this thing. That's almost certainly the, what is that? That's probably the bypass capacitor on the output tube cathode. Oh, this is upside down, and there's no cathode. Oh. 8. That's an 8. That's an 8. That looks more like an 8. I am totally mistaken. This capacitor is not the one I figured out it was. Didn't do a very good job of that, did I? Well, this 8 is definitely, it's way over here. Because all it's doing is just grounding this line here. So it can be anywhere in the radio. It happens to be over here. So, you know, I'm looking at this whole time, this older one, thinking, 8? How can that be 8? 8's got to be a electrolytic. How did they get 8 out of that? So the whole time I was scratching my head quietly. So the good news is, this guy is something else. He probably is okay. This one, who knows? Let's give it the voltage test since we're set up for that. What's the rating on here? Maximum SGEV 525. So we're not getting anywhere near that kind of voltage here. This might energize the radio too. We've got a number of parts in the radio. So if we see a heavy current, like a short or something, it's not necessarily that capacitor. Oh, come with me. Come on over here. Here we go again. Down on watching the current meter. $50 volts. 100 volts. So this is kind of a backwards way of not only testing that capacitor, but the whole high voltage circuitry in the radio. No leakage. That's good. So we got no shorted capacitors, no shorted wires, nothing terrible going on. So can't change this. Well, maybe I can change this other one if I figure out what it is. Why don't we try that again? Why don't we try figuring out what that one is again? Okay, well, I've stood here in silence studying this circuit diagram, trying to figure out what is going on with this capacitor I removed and then put back in. There's no question that the 8 microfarad, look, it even shows that it's electrolytic. It has to be this capacitor. This capacitor does not show up anywhere in this circuit diagram. I'm quite sure of it. So I don't know what it's doing there, so I'm going to leave it. I'm just going to leave it the way it is. I don't know why it's there. Maybe somebody added it later, or it's a revision on the original circuit or something. I don't know. We'll leave it there. So I think we're ready to operate this set. I think that's where we've gotten to here. So, but first, lunchtime. So after lunch, we'll give her a shot. Give her a shot. Hey, thanks for watching all this.